Hey everyone, we're going to take a look at some more applications of quadratic equations. Okay. A toy rocket was launched from the top of a building 50 meters above ground level. The height of the rocket above the ground level, h in meters after t seconds, is given by the formula blah blah blah. How many seconds after the launch will the rocket hit the ground? Solve by graphing. Okay, well, let's see here. There's a couple of ways that we can do this. One is we write out the equation, put it in descending form, standard form, and then we factor here as we've been taught before, and we figure out at 50 what our t is and all of that kind of thing. So let's do this. First, let's look at this scenario. So we have here, let's say 10, 20, 30, 40, 50. Okay, so that's meters. H is in meters and T is in seconds. We've got our arrows on our brackets, on our axes. And then we're going to see exactly where are we at 50. So we know that when T is 0, h is going to be 50 because 0 times that is 0 and 0 plus 50 is 50. So when t is 0, we're at 50. And then I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. And when t is 9, we're also at 50. So these are 2 points on our curve. We know it's negative here in front of the t squared, so we know the curve is concave down. Like any other gravitational pull on planet Earth problem, it's going to go launch, then comes down with gravity, goes slower, 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 maxes out, and then comes back down. And we need to know when the rocket is going to hit the ground. So we know the rocket will hit the ground when what is equal to 0? Well, when the rocket's on the ground, how high is the rocket above the ground? 0 meters, right? So when h is 0, we're going to have something that looks like this, goes up, back down, and then crashes. But it could be steeper, we're just guesstimating here. So we know that it's for sure. I did this to just show you that it's for sure after 9. So let's take a look here. Instead of doing all of this, like we used to with a table of values, now we can use what we've learned and fast forward the process. So if at 9 it's that, let's see what 11 is, because that's what they've given us here. I don't know why they skipped 10, but whatever. So here when t is 11, we'll plug that in. So we've got h equals negative 5 times 11, and then 11 minus 9 plus 50. And we have here negative 5 times 11 is negative 55. That is 2, and that's plus 50. So here this is negative 110 plus 50 is negative 60. So at 11, 10, 11, we're already way down here at negative 60. So I'm going to, which is why we do math in pencil, one of the many, 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 many reasons, I'm going to do something more like that. That's more accurate for our graph. Now what we need to do is see what's going on at 10. So when t is 10, let's see, negative 5, 10, 10 minus 9, and then plus 50. So here we've got, this is negative 50 times 1 plus 50. Okay, so now we've got negative 50 plus 50, and of course that's where h is equal to 0. And when does the rocket hit the ground? In English we say rocket hit the ground. In math we say h is 0. So we know, I'm going to make it even more accurate now, that when time is 10, we're going to hit the ground. And of course, even though in pure math this curve goes like this, in applied math the rocket, we're assuming, is going to land on the ground. It's not going to burrow down, keep going. It's going to hit that and then just sort of make a little crater and stop. So the answer to the question, the question is, how many seconds after the launch will the rocket hit the ground? The answer is, therefore, the rocket hits the ground, G-R-O, what am I doing? Holy smokes. G-R-O-U-N-D, after 10 seconds. Okay, let's take a look at this one now. The length of a flag is twice the width. Okay, sounds to me like a rectangle. Length and width. Find the width of a flag with an area of that. So, I like pictures, so I'm going to do that. There's our length, there's our width. L is the length, W is the width. If you draw this, you do not need to do this. If you don't draw this, you need to do this. You need to have this or this. But my suggestion to you is always draw a diagram, because I just find the visuals help. So, the length of a flag is twice its width. Find the width with an area of this. So, we know that length equals twice the width, and we also know that the length times the width is going to be area, which is 1250. Okay, so let's replace L with 2W, because that's what it's equal to. So instead of L, we're going to write 2W because they're equal. So 2W times W equals 1250. And then we've got 2W squared equals 1250. And then divide both sides by 2. We have W squared equals 2 into 12 is 6. 2 into 50 is 25. And the square root of 625, if you do not know, is 25. So let's see here. You'll notice W squared equals 625. And before, when I was graphing in a previous lesson, and we had something squared equals a number, we did the plus and the minus. So the reason why I'm not doing the plus and the minus is because in applied problems, where we actually are looking at lengths of flags and whatnot, you know there's no such thing as a negative length of a flag. You know -3 people didn't go on a bus. You know 2.6 people didn't go on a bus, right? So even though in pure math we end up with certain answers sometimes, when we apply it to real life situations like we are in this word problem, we need to use common sense and apply the restrictions required. So we're not going to look at the negative, we're just going to look at the positive. And you can write W equals, because W is greater than 0, right? It has to be positive. So now find the width of a flag. And we found it. Therefore, the width is 25, and what's our unit? Centimeters. Okay, let's do another one. A room is in the form of a rectangular box. There's my rectangle. And the length is 6 meters. The height is 1 meter less than the width. Okay, so if the height is the length minus, the height is 1 less than the width. Hold on, oh, a box. What am I thinking? I've got length and width and height. Got it. Okay. Let's change this up. So I'm going to just make a box. So I've got length, I've got width, and I'll call this, that's our width, there's our length, and here's our height. See, you got to read the question a couple times sometimes. So here I've got a room is in the form of a rectangular box. The length is 6 meters. So we've got length is 6 meters. The height is 1 less than the width. So the width less 1 is the height. The volume, which is length times width times height, is also 72. Find the dimensions of the room. So we already know that the length is 6, but we don't know what the width is and we don't know what the height is. So let's see what we can do. We know that 72 is going to equal this because they're both equal to V. Oh, we also need to solve by graphing, so hang on here a second. We know that, that length times width times height is equal to 72. We know that length is 6, and we know that height is width minus 1. So I'm going to call width, and height, I'm going to call it width minus 1. That's 72. So now I'm going to say this is 6W times this. Actually, I'm going to divide both sides by 6 and keep it simpler. So that means those cancel. So now I have W times W minus 1 equals, and 6 goes into 7 once, 1 left over, and 6 goes into 12 twice. Okay, so now I'm going to expand this, so W squared minus W, I'll bring that over, and now I need to graph this thing. Well, okay, let's see here. I think what I'm going to do, so they suggest that we use a table of values, but to be honest, we're in grade 10, we're not using table of values anymore. That's past. That's grade 9, grade 8. We're not doing that anymore. So let's deal with this in a way that we do with grade 10 things that we've learned. So one thing we could do is factor it. So let's see, what multiplies to 12 and subtracts to negative 1? Well, negative 4 and positive 3. So I'm just going to go down here. W minus 4 and W plus 3. And I'm just going to FOIL this out and make sure that when I do that I get this. That's W squared. That's plus 3 minus 4 is minus 1, and that times that is minus 12. Perfect. So now I know that W equals 4 or minus 3. W equals 4 or minus 3. And it's a word problem. So since W has to be positive, we're going to just go with W equals 4. Okay, so now that we know that W equals 4, and we know that this is an equation, we now can find the height. So height is equal to W minus 1, so height equals 4 minus 1, so height equals 3. So the question is, find the dimensions of the room. So I'm just going to write it up here because we're totally encroaching on the space for this answer here. Therefore, the dimensions are 6 meters, right, for the length, 4 meters, and 3 meters. So 6 meters by 4 meters by 3 meters. Used my units, perfect. Okie dokes. So now the hypotenuse of a right triangle is 1 longer than twice one of the other 2 sides. The third side of the triangle is 15. Find the lengths of the unknown side and the hypotenuse solved by factoring. So I want you to give that one a try. Pause this so you can write down the question, and we'll take it up next time.